Space, the final frontier. These are the voyages of Earth humans. Who among us will be brave enough to do what no Earth human has done before? To travel among the hot balls of fusing gas, the stars. How will we achieve this? Creating a faster-than-light interstellar mission. What will power our cosmic emissaries, our starships? These are the questions and more we will be answering in our next 2 coming videos. Hello everyone. We extend our best wishes to all. Be well, be safe. Today's podcast is an introduction to our next 2 coming videos. No time frame is set as yet. Soonish is all I can say. Why? Both videos contain a lot of quality information. We have already spent the better part of several months gathering data. In fact, more work has already gone into these 2 videos than it takes to write a thesis. And we will still need to create and piece together the animations and images. The first topic is about a kind of new Singularity Converter for powering a whole host of things, including starships. The second video is about the reality of achieving faster-than-light interstellar travel. For those of you who are new to our channel, we founded AsteronX and IRIS, International Research Institute for Space, in order to establish a faster-than-light interstellar mission to expand humanity beyond our system. Not because we're doomed here on Earth, because we need more than one planet to call home outside our system. All of our videos, the technologies we're working on, etc., are a part of Project AES, an interstellar mission. And with that, enjoy the podcast. Thank you. Okay, Renee, tell me about Singularity Converter. What is a Singularity Converter? How does the thing work?
Well, first of all, there's the name. It could be called a black hole reactor or singularity reactor. But the problem with that is that it's not really a reactor in the conventional sense. It doesn't fuse anything or cause any chemical reactions. It's an alternative name that's been suggested before is Singularity Engine. But I like the term Singularity Converter because it describes what it does. It converts mass to energy or energy to mass.
Now, this is for an upcoming video.
Oh, yeah, sorry, I should have mentioned that, yeah. This is an upcoming video, title pending still. Might just call it Singularity Converter and let it be kind of mysterious. Like the Musha jump drive. Like, what's that? Never heard of that before, I'm gonna watch that.
So,
hint, hint to any viewers watching this. Hint, hint.
So, you said that the video is already just over 1 hour in length. This makes this probably one of our longest, most detailed videos yet.
Longest, definitely longest.
Tell us, what are you packing in to this video?
Well, I mean, I go over... I'll tell the story here of how I first started getting interested in this. Well, obviously, there's been other science fiction works before, like Arthur C. Clarke's Imperial Earth, where he has a singularity to power one of the ships.
Right.
But it wasn't until, like, where I am, there's every early summer, late spring, early summer, there's wildfires routinely everywhere. And it was one night where it was choking with smoke, wasn't sure, had to evacuate sometime in the night. The fires was sometime close enough you could see it from one of the streets nearby. I couldn't sleep, so I was just trying to distract myself and was playing a game called Stellaris. It's like it's a space game where you control a space civilization. In the game, there's a particular building called a Class 4 Singularity, where it's a building, a single facility that probably is no bigger than a large factory, that puts the power output of a whole planet. And thinking about that, I was like, geez, with that kind of energies, I mean, talk about like dealing with wildfires, cleaning the air, cooling a building when you had all the doors shut because of smoke.
Whole lot of things.
All that would be trifles. And so I started thinking, could you really do it? And then sometime in that, I was overtired and hadn't slept, and remember talking to you about it the next morning. And I guess my mind just kind of started wandering and thinking, and I realized that, wait a minute. It takes less energy to spin up a black hole than you could extract from it. Because using what's called the Penrose Process, you can actually convert angular momentum into energy. Just like E equals mc squared relates the amount of energy bound up in an amount of mass, there's another equation that relates the amount of energy bound up in angular momentum. In the video, I suppose we'll put it on screen here. I'll read it out loud here, though, what it is.
Okay.
That's, sorry, I gotta find it here a minute. Which means the people who have actually already gone to the video and looking at it are seeing it before I can read out loud. Just a reminder that these podcasts aren't scripted. Much.
Yeah. We just have a few notes.
Or we don't.
No, what I like is the notes are, well, we've saved them in a place that we would never lose them. And lo and behold, because you're not familiar with it, well, there you go. You lost the note.
Here it is. So, the ratio between energy and angular momentum is E equals AC over lambda. Compared with the ratio between mass and energy, which is E equals mc squared. Lambda is the Planck length, which is 1.616255 times 10 to the negative 35 meters.
Okay.
It's ridiculously small. In the video I give a comparison of the size. The Planck length is as small to quarks as quarks are to a rapier. Or to give another analogy, the difference in size between a quark and the Planck length is the same difference in size between a rapier and the distance to Proxima Centauri.
Okay.
It's an extremely small size.
So
the energy of bound in angular momentum is related by the angular momentum A times the speed of light, so it's a large number, divided by the Planck length, a very small number.
Right.
Now, basic mathematics, you divide a large number by a small one, and you get a very large sum. Whereas the energy of mass is only the mass times the speed of light squared, which is still a lot, but nowhere near as much as angular momentum.
So,
now,
okay. Go ahead.
Well, but when you spin up a black hole, if you create one and spin it up by firing particle beams into it or something, or maybe when it forms, you shape the accretion disk, and so it spins up. I guess I'm getting ahead of myself there because I didn't describe. Like, wait a minute, are we talking about natural, artificial? But I'll come back to that.
Okay.
So, the energy required to spin up a black hole, we don't normally actually create angular momentum. We just transfer it. That's why it doesn't take much effort to get something spinning. In a spaceship, if you spin part of it, the rest of it spins the other way. They use that to rotate it around different ways and without having to use propellant.
Like a space station.
That's what I just said, yeah.
Yeah.
Well, if you make a machine and it makes a black hole, an artificial black hole, and spins it up, you can then use what's called the Penrose Process, which I won't go into here, but I did it in the video.
Okay.
Can't give everything away now, huh?
No, not at all.
So, using the Penrose Process, you can you can convert some of the angular momentum of the black hole into mass energy or photon energy.
Aha. Okay.
Now as based on that equation, that's an absurd amount of energy.
Yes.
Would
be, yes.
It's what is it? The amount of energy bound up in in the angular momentum of an electron orbiting a proton in a hydrogen atom.
Yeah.
Is something like 22 kilograms of TNT.
That's a
lot.
That's a lot. Wow.
It's equivalent of something. Oh, I'm going to look it up again, but no, that's right. Sorry, it's equivalent of 22 milligrams of mass. Which, if you imagine, if you had 22 milligrams of matter and 22 milligrams of antimatter, or rather, 11 milligrams of matter, 11 of antimatter, and annihilated them, the energy bound up in the angular momentum of an electron orbiting a single proton is equal to that much matter and antimatter annihilating. I mean, it's a decent-sized bomb. I mean, that's a lot of energy.
Ooh, ouch.
So when you imagine a giant black hole spinning much faster with much more angular momentum bound up in it.
Yes.
Well, that's a lot of energy.
So natural.
Meanwhile, the energy required to actually spin up an artificial black hole that you create, well, you're just transferring the angular momentum. It's nowhere near the energy that you could potentially extract from its angular momentum. It's much, much less. But it seems. But here's a quirk.
Yes.
If you take a machine that does that, okay, so you spin up the black hole. Now your machine is rotating the other way with the same speed, same momentum. If you then decelerate the machine, let's say you use retro rockets. Now you bring it to a halt.
Yeah.
Now the machine's stationary again, and can go and extract energy from the black hole it just spun up. Which will be way more energy required to spin the black hole up again, plus buckets and buckets of spare.
Yeah.
Now the machine's rotating again, though, because it's not. The machine extracts the energy, and the black hole is now spinning slower than it was. So you use a tiny fraction of the buckets of energy you just got from it, and you use it to spin the black hole back up to the original speed. The machine's rotating again. You decelerate it again. Now, if the rockets you're using to decelerate are photon rockets, then they can be powered directly from the energy you're extracting from the black hole.
Photon
which means
rockets,
the machine,
as in lasers,
or anything. But
okay.
So the machine can technically sit there, firing out photon rockets in many directions, not rotating, and just continually siphoning energy from the black hole and then spinning it back up. It seems like magic, like energy free. Where is this coming from?
Yes.
It also means it's limitless. Literally limitless.
And that's all due to the angular momentum of the black hole.
It took me a long time to figure it out, but I finally realized where the energy's coming from. Because the thing is, these mathematics are solid. There's even been a major paper on this. And this phenomena powers the jets that roar off the poles of a black hole.
Yeah, yes.
Naturally occurring black holes already use this. So it's not like the mathematics is an error. So where's the flaw? For a long time I thought that there's something unexpected that would make it not quite work that way, but then I realized, no, it worked. The energy is coming from the angular momentum of the universe.
Well, this is really an exciting prospect for future forms of power. This is substantial enough to power a starship. Not just a ST, slower than light starship, but it's sufficient to power an FTL starship. Once we have FTL capabilities.
Well, you're getting hit there a little bit.
That's how exciting it is.
I know it's.
But we're going to, of course, leave.
So without going more into the details of
Go ahead.
Yeah, without going more into the details of how the energy is extracted and all that, explained in the video. I will say this.
Mm-hmm.
The black holes normally seems like you'd have to extract it from naturally occurring ones.
Okay.
But the thing is that there's a couple different mechanisms. One outlined by Zubrin, I go into in the video. But the other one is that there's papers that have shown that if there's additional dimensions to the universe, the energy required to make an artificial black hole could at least at the smallest possible one, could be done within the LHC, the Large Hadron Collider.
Right.
Now, it hasn't done that, and I don't think it ever will, because while there's a huge pile of evidence growing that the universe is indeed more than just 4 dimensions, the evidence is saying that, and this gets into this new field called quantum relativity. I'll mention more about that later, or maybe in another podcast.
Okay.
The evidence is that there's another parallel negative space-time, where the speed of light is the lower limit rather than an upper limit, and where everything has negative energy.
Well, that's another way to look at it, isn't it? We look at it as an upper limit, but to this other parallel universe, it's the lower limit. That is interesting.
Yep. Now, by virtue of that, this is what a scientist, David H. Froning, realized back in the 80s, is that the imaginary number of a tachyon's imaginary mass, a tachyon's imaginary rest mass, it's a marker. It means this negative space-time. It means it can't be at rest in positive space-time, but it can in negative. He called the negative space-time superspace.
So it's almost like an opposite, but flipped from ours.
Yep. And in fact, there's more recent papers that showed doing that, you can flip the frame of reference and describe a tachyon as a non-tachyonic particle with a normal mass. And now everything else looks like a tachyon.
So the normal, what we refer to as sublight matter, now becomes FTL matter.
It's all matter perspective. And Einstein's equations have always had the negative in them. They just usually ignored because most scientists don't like what causality means.
Ooh, breaking causality.
Breaking causality.
Yeah.
Thing is, there's been a couple papers that have shown that, like this one paper that actually called the Quantum Principle of Relativity, published April last year, in 2020, that showed that if you add negative spacetime and FTL into relativity, it doesn't break causality. In fact, it reproduces the same results you get in quantum mechanics, but in relativity. If that's not a unification, I don't know what it is.
That is interesting.
Now, of course, that leads over into our own work.
Yeah.
Where I have the equation that I've put together that finds a quantum of time. I'm still trying to understand what the equation means, but once I get my head around that, we fully intend to publish a paper on it.
Excellent. Yeah.
So, it turns out, this is explained in the video. In fact, fair warning, the video is about half about tachyons because it's necessary to explain it the long way first to understand this next part. Yeah. Basically, we can create, with current technology, a kind of radiation that's partially tachyonic. And this partially tachyonic energy allows you to access this negative spacetime and really drop the energy requirements to make an artificial black hole. Enough that to create a useful black hole, using this plus another method outlined by Robert Zubrin, 22 nuclear power plants should be enough to do it.
Well, that's a lot of nuclear power plants, but
that's definitely more feasible. It means a large solar array in space or an array of deep geothermal plants should be able to do the job. And then we have infinite energy, limitless energy at our disposal, not in 100 years, 1,000 years, but my gosh, in the next decade or two.
Yeah,
potentially.
So
it's crazy.
What type of time frame are you projecting that we would be able to create one of these singularity converters, power sources?
Within 5 to 10 years after the first solar array goes up in space. But they're already working on that right now. That could happen itself in the next 10. So sometime in the next 2 decades, I'd say we have our first singularity engines, singularity converters.
So this technology, just for everybody to know out there, this technology is based on existing technologies. It's something that's been greatly overlooked because, well, most people...
Well, hold on. Not exactly existing technologies, but...
Okay.
It's built out of existing theories and technologies. This isn't pie in the sky. This is all well grounded. Even if it's kind of obscure work, some of it, it's all very well grounded.
Okay. That's important. A lot of people, they hear a lot of theories and a lot of ideas, but when it comes to something doable, feasible, practical, that's far few in between. And I think most people want to hear good news.
Well, they want to hear good news that seems realistic.
Yeah, this is good news because it's, as you said, based on sound ideas.
Yeah. I also want to say this, that as much as it seems like we are always speak perfect to the fact that you guys often say we're robots, and some of you anyway, I will neither confirm nor deny this. Personally, honestly, myself, I'm often really nervous when recording these things.
Well, all I have to say is my logic is undeniable. My logic is undeniable.
Yes.
My logic is...
But yeah, it's not quite... The videos come across fairly flawless, but there's a lot of nervousness and anxiety that goes behind them.
A lot of editing that goes in between.
Like even right now, I'm a little tiny bit nervous.
Thank goodness for electronic editing. So tell us, what are you going to be covering in this long video, this packed full of information video?
Well, artificial black holes, singularity mechanics, like creating a black hole, extracting energy from it, controlled singularity, artificial sun satellites powered by singularities.
What you can use this power source for.
Yeah, black hole rocket, not a Hawking radiation one, but instead you use it like the black hole's natural relativistic jets. You just create a small one and do that in a ship. It has potential to butt up right against the speed of light.
Of course, I think everyone's going to want to know the big question.
Yes, the big one, which I... Oh, what's that?
Will this power an FTL starship?
Okay, now that is the last part of the video, but can't really put anywhere else, and it leads into... As much time as I spend in the video on tachyons, there's more to say about it in more depth and things to explain, especially for those who aren't well versed in particle physics.
And more up.
So
up
I have
to
to. Unfortunately, I had to leave just a relatively small section about the FTL side of it, the FTL powering mechanism of the black hole, where you can power an FTL ship. I had to leave that to a small section at the end. That's almost a tease, because I'm going to have to make a follow-up video on Froning and quantum vacuum power and fast light travel, and more into the black hole. That's going to be a follow-up video, which probably will run half an hour at least on its own. So there's even more coming, but one thing at a time. I need to sleep and eat and breathe occasionally.
Well, I thought robots only required electricity.
You're right, I'm mistaken. My apologies.
Yes.
What was the topic being discussed?
Okay, well...
But I will say this. It turns out that you manipulate the black hole correctly, you can actually get basically tachyons out of it. In fact, you might not even... All black holes might even do that. There's a paper that talks about how you might be able to use this black hole in the center of the galaxy as modified in a way, or a similar black hole to create a wormhole, basically.
Ooh.
It means that even an ordinary spinning black hole might be spitting out tachyons, because the thing is, while nothing can escape the event horizon of a black hole, that only applies if you're bound to less than the speed of light. If you can go faster than the speed of light,
Well,
Because tachyons, don't forget, tachyons go faster the less energy they have, which means the more the black hole tries to pull it in, the faster it slips away. So there might actually be tachyons spraying out of black holes and we don't even realize.
Well, we can't even detect them. They're faster than our detectors are capable.
Neutrinos and axions are hard enough to detect. There's been a possible axion confirmation.
Yeah.
But it's extremely weak signal. Those are hard enough. Gravitons, we can't detect single gravitons. Only mass of them, gravitational waves. So detecting tachyons, well...
That's for the realm of seemingly science fiction for the moment.
Yeah, there is an experiment outlined by Musha, the same one behind the Musha jump drive, though.
Yes.
That might actually, if it's actually funded there in Japan, and maybe other countries want to join in, it would actually conclusively prove tachyons, without a shadow of a doubt.
That is interesting, yeah.
And then that's also a subject for another video.
Yes, so I smell several videos coming.
Now, I think it's time that you talk now about what you're up to.
Okay, I just wanted to make mention that this
You can't delay it too much longer.
Not too much, no. I just wanted to make mention to the fact that we're going to be, especially now, providing more videos outlining an interstellar project and all the things that are necessary. We have
a new website coming.
A new website, new videos with new video formats, and so on and so forth. We are not holding back.
We're up to something.
Yes, we're up to something.
We're up to a much larger project.
Yes.
It's what we've been really working on this whole time since we started AsteronX in 2017. But we've only just in the past 2 years really put together into solid words what we're really trying to do and figured it out solidly for ourselves.
That's right.
It's going to be up on the new website, which will hopefully be up sometime in the next couple months.
Yeah.
And it's also going to be discussed in upcoming video.
So on that note, then I'll transition over to mine.
So I'll start this off by asking you.
Yeah.
What is your video about? About reality of FTL or something?
I have titled it "The Reality of Achieving FTL," that is faster than light interstellar travel. Now I'm going to be walking you guys through you're going to learn how an FTL mission works. We're going to also talk about how to go about achieving FTL travel, that is interstellar. We're going to talk about what the difference between transstellar and interstellar travel is. We'll be looking at examining realistic near-term starships that are slower than light, as well as aerospacecraft. We're going to then also look at what a FTL starship, of course, will look like as well. We can't do the one without the other. We're also going to be talking about why. Why do we need to go interstellar? That's a big topic. There's a whole lot of reasons. Under each topic, there's a lot of content. I don't want to give away it too much. But finally, though, we will also be talking about what all of this can teach us about becoming a faster-than-light interstellar species. How is this going to affect Earth? What's it going to do for individuals? Things like that. It's a big, huge topic. It's taken me a long time to put together. But just so you have an idea, right now as it stands, you would think that with everything that SpaceX, Blue Origin, Virgin Galactic, I mean, sure, they're reaching just into space. Of course, SpaceX has gone beyond and can go beyond. They can actually reach Mars. They will soon. But you would think all these things that people are doing right now, these various companies, would show us how we are going to master getting into space. Well, let me tell you, folks, this is not at all how we're going to master getting into space. It's only the necessary first step toward achieving a deep space travel.
That's not to say that what SpaceX is doing is amazing and absolutely vital and necessary. But it's also not how we're going to perfect space travel.
That's right.
And really get into space in a big way.
That's exactly right. But in the video, we will, and I'm not just going to tell you this is not how we're going to master getting into space. You would think, as I said, you would think we have already mastered getting into space. No, we have not. There's reasons for that, and I go into detail as to why. I'll also tell you how we are going to achieve mastering getting into space. And the day we can hop into a waiting spacecraft and jump into space just like you could going to the next state in an airliner, that's when we have mastered. So that's about the most I'm going to reveal. We're going to leave the rest of this exciting topic in the video. But no one to date has ever put together an interstellar mission, let alone planned one. Actually, it's the other. I said it backwards, didn't I? See, this is no one has ever planned an interstellar, and especially a faster than light interstellar mission, let alone put one together. There, how's that? I'm not going to cut that bit out and refit it into place. You guys will have to just take it as it comes. Anyway,
it's a podcast. That's what it's about.
That's right. Maybe they should call it pod. No, I won't say it. Anyway, that is the topics, the two coming videos.
Hey! You haven't said nearly enough about it yet.
Well,
you're not getting off that easy.
Okay. Let's.
All right. So how in depth is your video? Does it cover just the broad sweeps? Is it really in depth? Like, what can we expect from the video?
Okay, we're going to get into details. I'm going to walk you guys through the beginnings of creating an interstellar faster than light mission, all the way to the day we actually could achieve interstellar travel. So there's a lot of information. This is going to be probably well over an hour-long video, unless I decide to split it up into pieces, which I'm not really looking for.
That's a good question. That's actually a good question.
Let's pose it to you guys.
Would you rather, actually for my video too, would you rather, in this case, these two hour-long videos, or would you rather say 2 half-hour videos?
Yeah.
And please don't answer what you think will be best for our channel's health. Answer what you would rather watch.
Yeah.
And if you would like to watch a long one, but with certain conditions, like in other words, if it's this way you wouldn't watch it, but if it's this way you would, then let us know.
I would also
if you have any ideas for the name for the videos, like Singularity Converter, Singularity Engine, please give us some ideas in the comment. I have not finalized the name yet.
Yeah, and of course we would like to know what kind of information do you want to know relative to what we are doing. And the whole thrust of AsteronX /IRIS, International Institute for Space.
International Research Institute for Space.
Yes. What would you like to see from us? Now, yes, a lot of people would like to see some technology. We are working.
Can I say something there?
That. Yeah, go ahead.
I know I talked a lot, but sorry. I'll just say this quick, then I'll let you continue. While it seems like actually building stuff would be better progress, the thing is, we're trying to basically build a real-life Starfleet. And that sounds like complete fiction, but we're trying to build at least a precursor to it. Something along those lines. We think it's vital and important for humanity's survival to have something like that. We'll explain in other videos and on the website more about what that means, what I mean by that. But
yeah, the website
in regards,
outline that more so.
Yes. In regards to progress, with a project like this, progress isn't building things. Well, it is, but progress isn't so much that. It is more getting more people together and on board and working on this collective project, kind of like the Mars Society, is more progress than actually building something right now. So I just wanted to say that so you guys understand, because there's been some people that seem to have the idea that if we don't build something, we're not making any progress, and I just wanted to address that misconception.
Yeah,
anyway, continue.
The main thing here is a faster-than-light interstellar project has to start with the organizing of the organization. We have to piece together how we are going to go about this mission once it is created. Also, and I think a lot of people look past, before you can break ground and bend metal, as they say, you need to know what you're going to be bending first and why and how you're going to be bending that metal, so to speak, in order to develop and bring these technologies to the forefront of reality, to engineer them. So there's a lot of preparation beforehand. The day we actually begin to put more effort into bending metal, so to speak, engineering and building these various technologies, and there's a lot of them, more work actually has to take place. It's going to be relatively easy to engineer and build these technologies. Now, I'm not saying that they're easy to build, engineer, and build, but the precursor, the build-up to that point, is far more involved than anyone has an idea about. This is one of the reasons why no one's ever have done a comprehensive plan for a faster-than-light interstellar mission. So that is something to take into consideration. And on that note, I think we're right about the 36 mark. Should we conclude it?
Yeah, I suppose.
Did you have any?
So.
Okay, nothing more to add? Okay.
Not really. I mean, not without basically starting to describe the video.
Yes. Well, this is more of an introduction to the videos. We might actually create, if I decide that I'm going to, let's say my video is a 2-hour-long video, I might actually create a trailer about 2 minutes, 30 seconds, something like that.
Yeah, I was actually thinking of doing something similar.
As a prelude to the actual video, so that it'll whet your appetite, get the juices flowing, and you'll know to look for it. Well, then on that note, I think we should wrap this up. Well, I thank everyone for being here and listening to our podcast. Any suggestions, please leave the suggestion in the comments, and we do read the majority of them. So on that note, till next time, keep wandering about space. Thank you.
Bye.